Here's problem 429. An artillery shell is fired with initial velocity of 300 meters per second at 55 degrees above the horizontal. Explodes on a mountainside 42 seconds after firing. If x is horizontal and y is vertical, find the xy coordinates where the shell explodes. So we're going to launch a shell at a velocity of 300 meters per second and at an angle of 55 degrees above the horizontal. It's going to go through some trajectory here and eventually hit a mountain. So we'll have some coordinate here of how high it hit, which would be delta y, our displacement in the y direction. And then we'll have another coordinate here, which would be delta x, which would be our displacement in the x direction. And those two displacements will give us the coordinates. Now if we look at our initial velocities, our initial velocity in the y direction is going to equal v naught sine theta, and that will be equal to 300 times the sine of 55 degrees. Let's make sure this is looking like that. And that's equal to 245.7 meters per second. So that's our v naught y. Our v naught in the x direction is going to be v naught cosine theta, which would be 300 cosine 55 degrees, and that is equal to 172.1 meters per second. So that's our v naught in the x direction. So those are our initial velocities in y and x respectively. If we look at just the y direction, what do we know? Well, we know our v naught is 245.7 meters per second. Our acceleration will be a negative 9.8 meters per second squared. Our time, we're told that this is in the air for 42 seconds. So our time is 42 seconds. So that's what we have here. And we wish to find delta y. So we have three kinematic variables, and we want to find the fourth one. So we have delta y is equal to initial velocity in the y direction times time plus 1/2 acceleration times time squared. And that's going to equal 245.7 times 42 plus 1/2 times a negative 9.8 times 42 squared. And that's equal to 1,676 meters. So that's our displacement in the y direction. We want to find the x direction, so in the x direction, what we know, our initial velocity is 172.1. Our acceleration is 0. Our final velocity is the same, meters per second. Our time is also 42 seconds, and our displacement, delta x, is what we want to find. So we have enough information to find delta x. We have 4 variables and we just want to find delta x. We have several things that we can use, but let's use this. v naught t plus 1/2 acceleration times t squared. In this case, the acceleration is 0, and so this is equal to our initial velocity, 172.1, times our time, 42 seconds. And that's equal to 7,228 meters. So that's our x displacement. We have our y displacement. So our xy is 7,228 and 1,676. Those are our coordinates for where the projectile will hit the mountain.